Hello, this is Dr. Lori. Welcome to this discussion on association and causation. I have two different ideas to share with you, and they both kind of come back around to this whole notion of the difference between association and causation, really talking about those two things. And the first one has to do with sufficient cause. And a lot of times what we think about is that there are several different things that have really contributed for any given person to have a particular outcome. So if we think about something, for example, like lung cancer, and we think of a specific person, maybe Pat has been diagnosed with lung cancer, and for Pat, there are several different elements that really all had to come together in order for him or her to develop this particular outcome. If we are talking about this sufficient cause model, then what really this comes down to is that if any one of these pieces of the pie were missing, there would not be enough things that came together in order to cause that particular outcome to have occurred. So if the outcome here is lung cancer, perhaps one of them would be cigarette smoking. Perhaps one of them would also be a genetic predisposition. Maybe for another piece of this particular sufficient cause for Pat specifically, there may have been some other exposure. Sometimes these pie pieces could be a specific thing that happened at a specific time, either in utero development or at a specific time of development during childhood or adulthood. But for that specific person, this collection of things are the sum total. If we had perfect knowledge of all the different things that had to come together in order for that outcome to occur, then these would be those items. Now, in order for this to really be a piece of the puzzle, if we were, say, to have removed A, then B, C, D, and E were not sufficient to have caused that particular outcome to occur. If we look at, say, a different person, and we draw Joe's sufficient cause for that same outcome, there may be many more things. Maybe they share A and C, but F, G, H, and I are different between those two different individuals. And the same concepts apply, where if any one of those pieces is removed, then the things that are remaining are not adequate to have caused it. Otherwise, A, C, F, G, and H would have been sufficient cause all by themselves without I being present. So if we think about the notion then of causation, a piece of it is that if that particular thing were removed, if we think about A, which we could consider to be cigarette smoking, leads to say lung cancer, then if A is removed, then lung cancer then does not occur. So for any person that has that particular element as part of their sufficient cause model, then that particular item was considered to be what's called a component cause. In other words, it was a component, a piece of that particular sufficient cause model. Now, there might be another person who doesn't have A. They have B, C, H, I, and maybe J. And so this is perhaps Brent. Has the same outcome, has the same manifestation of disease, but no A. And so if that's the case, then A isn't automatically necessary for every single person to have that particular outcome, say lung cancer. And this for a while was the argument that cigarettes do not cause lung cancer because every single person who comes down with lung cancer isn't necessarily a smoker. And every single person who's a smoker doesn't automatically get lung cancer. So if something is a necessary cause, then that means that every single person who has that particular outcome must automatically have that. Now, that the usual time that that occurs, that to have a necessary cause, would be for infectious diseases. So, for example, tuberculosis. Every single person who comes down with tuberculosis has to have been exposed to the microorganism that causes tuberculosis. Everybody who comes down with influenza must be exposed to the influenza virus, and so that's considered a necessary cause. Sufficient cause means that that particular collection was sufficient. TB all by itself may not be sufficient to cause every single person who is exposed to come down with active tuberculosis. So that brings us to the next set of ideas, which is Hill's criteria. Now, a lot of people have started using Hill's criteria as kind of almost like a checklist of things that we want to check, and make sure that for that particular thing, say cigarette smoking and lung cancer, that if we check off all the boxes, then automatically we have causation. There are a lot of things that might be associated that aren't causal. In other words, we might be able to remove them and it doesn't necessarily stop that particular progression for that particular individual. So don't think of these as necessarily a checklist, but as more of a conceptual framework, ways to think about this whole notion of causation. So the first one, and I'll scroll up so that you can see a few more of them. The first one is strengths of association, and the idea here is that the stronger it is, then the more likely that is to be causative. And that's not always necessarily the case. There are some things that can be very strongly associated, but that are not automatically causal. In other words, if we removed them, then the outcome would not go away. With strength of association, for example, if we think about lung cancer, if lung cancer is strongly associated with cigarette smoking, it's also associated with some other things that may not be quite as strong, but are still causative. So, in terms of lung cancer, cigarette smoking is a strong predictor. Sometimes we see things that are, say, relative risks or odds ratios or correlations. Those are measures of association, and the stronger they are, the more likely then that is to be something that is causative. But we have to be careful not just to consider that to be a check mark. Consistency of repetition. With that, I like to think about people repeating the same kind of study in maybe different populations or different age groups, or repeating it at different times, different researchers, different study populations. And when we consistently see that repeated over and over again with different researchers and methodologies, then a lot of times we can put that into a meta-analysis. So that consistency over and over of different people finding the same thing is what we're looking for there with consistency of repetition. If different studies found that was not necessarily the case, then that would be less of a criteria for causation. Specificity is the one that has to do more with usually infectious diseases. So one particular infectious disease agent causes one disease. Tuberculosis causes active TB disease. An influenza virus causes influenza. This doesn't hold as well with some of our chronic diseases. For example, cigarette smoking causes a variety of problems. It leads to heart disease, it leads to different types of cancers, and so the fact that it leads to a variety of different things doesn't necessarily mean that it's not causative, but specificity does lend to thinking of something as causative. Time sequence is the one criteria I think that just about everybody can agree upon is very important. In other words, the exposure must happen before the disease, before the outcome. And if it happens in reverse, if we have the disease and then after that somebody is exposed to a particular thing, then we would think of that as being not causative. So if a person has a heart attack and then they go to the emergency department did not cause their heart attack in that particular situation. So just because being in the emergency department is highly associated with having a heart attack doesn't mean that it caused it. So the exposure to something needs to happen before the disease occurs, and this is the one very supported that would really need to be there pretty consistently. Biologic gradient simply means that the more somebody is exposed, either in the size of the exposure or the time, so number of years of exposure, the more that would be considered to be. So if we have some kind of exposure over time, then we would think of that as being a biological gradient, or that they've kind of accumulated a certain amount. So pack years of cigarettes or exposure to certain occupational hazards over time, the more somebody is exposed, even lead for children, then the higher the exposure, the more severe the disease that we see. These next two, plausibility and coherence, are often sort of left out of current conversations because often this is, can we make a plausible or a coherent argument for that particular exposure to be causative? So often with plausibility we think about biological mechanisms. With coherence we think of as we're going along through the research process from bench research then to research among humans. We can often convince ourselves that, oh yeah, that sounds plausible, or that sure, that's coherent, and wouldn't necessarily support the notion of causality. So just be a little bit careful with those, but they are considered part of the criteria. These last three have to do with whether, so the next one, experiment, has to do with whether if I assign exposure to somebody, then that lends greater credibility to the notion that it is causative. Often people have certain behaviors where they tend to be healthier, they are more likely to drink water, they possibly are more likely to exercise. So a lot of exposures really come collectively, and it's very hard to tease them apart. Somebody who's a cigarette smoker is much more likely to also be a coffee drinker. That doesn't mean that all coffee drinkers are cigarette smokers. We know an awful lot who aren't, but we do know that those two things go hand in hand. So sometimes it's hard to tease them apart. If we do an experiment where we assign exposure, then it removes a lot of those chance associations that are just occurring. For analogy, a lot of times we can think of another example where, say, maybe viruses causes cancer. If one virus causes a certain kind of cancer, then maybe another virus could cause a different kind of cancer. And so that could be an analogy. With alternative explanations, we often like to think of kind of those same things that I was talking about in an experiment where, well, is there some other explanation of why those two things would be correlated with each other but not causative? So in terms of cigarette smoking, if we think about the cigarette lighter, not all people who carry lighters are going to automatically have a higher incidence of lung cancer, for example. So if we can think about maybe alternative reasons that there would be some kind of an association. I think one of the recent kind of spoof articles that was published talked about a relationship between women having heart disease and women wearing pantyhose. And if you think in the world of the different societies where women wear pantyhose, they're probably they live longer, they possibly have more stress, they're more likely to be exposed to things that lead to heart disease. So if we took the pantyhose away, it wouldn't necessarily make the heart disease in that particular segment go away. So think about all the alternative reasons, those other explanations that could be the real underlying reason, instead of that particular relationship between those two variables. So that's a quick overview of the whole notion of association and causation. Thank you for joining me.